Good question.
Okay, what's your question?
Integral of tangent 4x secant to the fourth of 4x dx.
Okay. So this is easy. That's how you do it. Do you have any questions or anything?
I have a really quick question. I didn't understand it the first time.
Okay.
It's the integral of tangent 4x secant to the 4x dx.
Okay, what was your question? Just starting it off or the whole thing? Or?
Yeah, I don't really know where to go.
Okay. What's secant squared x without the 4? What would that be?
1 plus tangent.
Okay.
Yeah.
So 1 plus tangent x. But since we have this 4,
1 plus tangent 4x.
Right? It's this way, or is this squared?
I think it's like that.
It's like that. Are you sure?
I can check.
You have to be confident in what you're telling me. I'm listening to you.
Yes. Yeah. No, it's squared. You're right. It's squared.
Okay, so now that we have this, what do we want to do?
We can use U substitution.
Okay, and why use substitution?
Because we can get rid of the secant.
This one?
Mm-hmm.
Good. Then what's d?
Secant squared x. And then divide the 4 on the other side.
Good, because
That
if
way,
you use chain rule, this
yeah.
is 4, but you just want to divide it. Why did you divide it?
Because the whole point of like the substitution was so that you can eliminate something from the equation, well, from the original function.
Okay. Better answer?
Hmm? Thank you.
Yeah.
It makes a lot of sense.
Do you have a problem that you want to go over?
I really don't understand how to solve for this integral here.
Okay, so
That involve the ln's.
Okay, so this is using U substitution. So let's try it. They give us that U equals ln of x. So this is pretty easy. Just wherever there's an ln of x, just put a U. There's an identity says that this is equal to the arc sine of U plus C.
But so this has to do with derivatives? Like why, is there a correlation with just how we learned derivatives before and now this?
No, this is just a new section. So you basically kind of just memorize the rules and
Okay.
all of these are the U substitution. Is that what you don't understand, or
No,
you don't
I guess that
understand?
I guess this is where they give you the use substitutions, and I guess then later on it's kind of like you need to
When
know
you
what
have
you have to figure out your own use substitution.
Okay.
But,
But you do understand
all
like
I know
simple integrals where you don't have to substitute? Or you
not
do?
really. I know that you have to find some sort of as far as I'm a little sketchy on that. But is that where you pretty much realize, oh, this is an antiderivative of something else, and then you
Let's
do a
start.
plus C?
I want to start with like a simple thing just to see like where you are, to see what the confusion is. Do you know how to integrate this?
Oh wait, am I doing something where it's x to the fourth over 4?
Yes.
Okay.
But why? Why did you do that?
Because there was something that said that you have to do x to whatever the power plus 1 over that power that you've
Okay. If I were to ask you to differentiate this, what's the derivative of x to the fourth?
4x to the third.
And why?
Because there's a rule where they say taking it, like, x to the r is r times x to the power r minus 1.
What number it is, it's always going to be one. And it's going from the solution from one to
You just have to realize some of these guys are expansions of functions. You know how like e to the x was the main guy? 2 is 1 over 0.8. And
And then when you just change something on the inside, you still change that. But then once you do that, you'll simplify it down. So the thing is that one word is since you turn the derivative of this one,